Slot milling with a trochoidal strategy redefined, highly effective, innovative, and extremely flexible. In this tutorial, as always, it's explained briefly, precisely, and in an easy-to-understand way. To begin, we go into the Program Manager and open a new or existing G-code program. As you can see, the program usually starts with the technology header and the machining parameters that follow it. In cycle 800, the axes are set to 0. Following that comes the definition of the workpiece, that is, the parameters for the raw stock description. Then the familiar tool call, the spindle speed and direction of rotation, and moving to the first position above the workpiece. If you want to mill a slot, you of course need a contour. This contour consists of 3 simple lines that form what's known as a zigzag contour. I moved this contour description to the end of the program after M30 for better clarity. To mill a slot or a contour, you first need a contour call. We give the contour a unique name. Next, the actual technology, the SMTE cycle call for trochoidal slot milling, is selected. To do that, we go to the extension button on the horizontal soft key bar and select Additional Cycles. You can see the selection of the installed SMTE cycles. We select Trochoidal Milling Contour Groove. When you look at the input screen, you're in the familiar SINUMERIK Operate User interface. We set the program name to Auto, then the workplane, Climb or Conventional Milling, then Retraction Plane, then the safety clearance, the feed rate, the spindle speed, and the direction of rotation. Next come the familiar technology selections, roughing, floor or wall finishing, and chamfering. We need roughing. After that, you can choose whether to smooth the wall or not. You can see it very clearly in the animated elements on the left-hand side. The next input field offers the options to machine either along the contour center line, to the left of the contour, or to the right of the contour. Our reference point in Z is 0. Z1 is the groove depth and W is the groove width. DZ describes the maximum depth of cut. The PHI value is very important and interesting. It describes the maximum wrap angle of the tool, which defines the lateral radial infeed. This is a key characteristic of trochoidal milling. Under UZ, the finishing allowance is set in Z and under UXY in X and Y. In the next 2 fields, the system offers a choice of how the slot is to be started and how it is to be finished. 3 options: open, closed off straight, or closed off with a semicircle. A really interesting function. This is what makes the whole thing properly complete. After that, you can specify whether and how the corner radii should be machined. Of course, you can choose what radius size to apply to the corners. Finally, the plunge feed in Z is specified. And of course, the retract option mustn't be forgotten. Afterwards, the cycle is transferred into the NC program. Thus, the roughing is finished. Now we copy the programmed sequences and insert them after that to finish the contour and avoid having to enter everything all over again. First, the contour call again. After that, we simply adjust the technological parameters. Roughing becomes finishing. Just change the corresponding value in the input screen, very clearly visible in the animated elements. As the last step to complete the machining, do the whole thing again to add the chamfer. Here too, the input screen is reduced to the parameters required for chamfering. The animated elements illustrate the different machining operations graphically, which provides very good process reliability. At the end of the program, we retract, and with M30, the program is finished. In the horizontal soft key bar, we select the simulation function to start it. The SINUMERIK Operate simulation shows graphically what has been programmed. We get a brief visual confirmation of the machining process. In Run My Virtual Machine, we use the Maschinenraum-Simulation, meaning the digital twin of our real machine. Here, the production process can be seen in an absolutely realistic way, including the clamping devices and parts at risk of collision. By pressing the Execute button and then Cycle Start, we start the machining process. It's very easy to see that the tool plunges into the groove to its final depth along its cutting length and makes effective use of the full cutting length for the machining process. It's precisely this key feature that ensures the most efficient results with minimal tool wear. You can see very clearly how the corners are milled out to the specified radius. Afterwards, the finishing pass is carried out to even out the surface structures from the roughing operation. The following chamfer tool, which applies the 45-degree chamfer, was assigned a different color to visually highlight the differences between the individual tools and machining strategies. That wraps up our topic, SMTE trochoidal slot milling. Slot milling with a trochoidal strategy redefined, highly effective, innovative, and extremely flexible.